Here is the exercise 1.3. Question number 1. Write the following rational numbers in decimal form and also state which are terminating and which are non-terminating repeating decimals. I shall repeat. Write the following rational numbers in decimal form and also state which are terminating and which are non-terminating repeating decimals. The first bit 3 by 8 and the second bit 229 by 400, third bit 4 1 by 5, fourth bit 2 divided by 11 and fifth bit 8 by 125. Here is the solution for the first bit. 3 divided by 8. You cannot divide 3 with 8, therefore keep 0 point and it will be 30 now. In 38 3 times, 3 8s 24, the remainder is 6. You keep 0 beside 6 so that it is 60. In 68 7 times, 7 8s 56, now 40. In 45 times, 8 5s is 40 and the remainder is 0. Therefore, 3 by 8, the quotient is 0.375. Okay, if you divide 3 with 8, you got 0.375. We know that 0.375 is a terminating decimal. Now look at the second bit. Look at the second bit, 229 divided by 400. You cannot divide 229 with 400, therefore keep 0 point. Then it will be 2290, 400 5 times, 5 400s is 2000. If you subtract, you will get 290. You write 0 beside 290, it is 2900. Now in 2900, 4 7 times, 7 4s 2800. If you subtract, you will get 100 and keep 0 so that it will be 1000. In 1000, 400, 2 times, 2 400s is 800. So that you will get 200 now. You will get 200, keep 0, it is 2000. 400 and 2000 5 times. 5 400s is 2000, the remainder is 0. Therefore, 229 divided by 400 is 0.5725. It is also a terminating decimal. Now look at the third bit. We have given a mixed fraction. Let us convert it into improper fraction. 4 5 is 20 plus 1 is 21 by 5. Now divide 21 with 5. 5 in 21 4 times, 4 5 is 20. If you subtract 1 is the remainder, keep point so that it is 10. Now 5 in 10 2 times, 2 5 is 10, the remainder is 0. Therefore 4 1 by 5 is 4.2. Again it is a terminating decimal. Now look at fourth bit now. 2 divided by 11. Take 2 and let us divide this 2 with 11. As you cannot divide, keep 0 point. It is 20. In 20, 11, 1 time, 1 into 11 is 11. If you subtract 11 from 20, you will get 9 remainder. Now keep 0, 90. In 90, 11, 8 times, 88. And again you will get 20. 1 time, 11. If you subtract, you will get 9, 90. In 90, 11, 8 times, again you will get 2 like this. Therefore, 2 by 11 is equal to 0.181818 and so on. It is non-terminating. It did not get remainder. Therefore, 2 by 11 is non-terminating decimal. And at the same time, if you look at this decimal part, 1818, this 18 is repeating. Therefore, it is a recurring decimal also. 2 by 11 is non-terminating and recurring decimal. Next is question number 2. Here is the second question. Without performing division, state whether the following rational numbers are terminating or non-terminating and recurring decimals. I shall read again. Without performing division, state whether the following rational numbers are terminating or non-terminating and recurring decimals. The first bit is 13 by 3125, second bit 11 by 12, 6th bit 23 by 2 cube into 5 square, 7th bit 129 by 2 square into 5 power 7 into 7 cube, and 10th bit 77 by 210. Here is the first bit. Now before solving this, we should know that if the denominator of a fraction is in the form of 2 power n into 5 power m, where of course n and m are non-negative integers, then the fraction is a terminating decimal. Otherwise it is non-terminating recurring decimal. I shall repeat. If the denominator of any fraction is in the form of 2 power n into 5 power m, where n and m are non-negative integers, then the fraction is a terminating decimal. If the denominator is not in the form of 2 power n 5 power m, then the fraction is a terminating recurring decimal. Now let us see the first bit now. The first bit is 13 divided by 2125. Now take the denominator 3125. Now let us write this 3125 into prime factors. 3125. What is the units digit? Units digit is 5. Therefore it is not divisible by 2. Is it divisible by 3? You verify. 4 plus 2, 6 plus 5, 11. Not divisible by 3. But as the units digit is 5, it is divisible by 5. Therefore it is 5 into, in 31, 5 6 times, in 12, 2 times, and in 25, 5 times. Therefore you can write 3125 as 5 into 625. Now again this 625 can be written as 5 into 125. This 125 you can write it as 5 into 25. This 25 as 5 into 5. Therefore in total 3125 can be written as 5 power 5, which is in the form of 2 power n into 5 power m. You may have doubt that where is 2 power n. You may be confused that whether 2 is there or not. Here, even though 2 is not a factor of this, here if you look at this statement, 2 power n and 5 power m, where n and m are non-negative integers, means they may be 0 also. Therefore, this is 2 power 0 into 5 power 5. Denominator is in the form of 2 power n into 5 power m. Since it is in the form of 2 power n into 5 power m, the given fraction is a terminating decimal. Now look at the second bit. 11 by 12. The denominator is 12. Now let us write this 12 as 2 into 6. This 6 as 2 into 3. Therefore this is in the form of 2 square into 3, which is not in the form of 2 power n into 5 power m. Why? Besides 2 and 5, 3 is also a factor of 12. Therefore this is not in the form of 2 power n into 5 power m. Therefore the given fraction is non-terminating recurring decimal. And the fourth bit now. 23 by 2 cube into 5 square. 23 by 2 cube into 5 square. Look at the denominator. 2 cube into 5 square, which is in the form of 2 power n into 5 power m. So the given fraction is a terminating decimal. Next is 7th bit. 129 by 2 square into 5 power 7 into 7 power 5. 129 by 2 square into 5 power 7 into 7 power 5. Here the denominator is in the form of 2 square into 5 power 7 into 7 power 5. Here even though 2 and 5 are factors, the 7 is also a factor in this. But except 2 and 5 there should not be any factors. But since 7 is a factor, the given denominator is not in the form of 2 power n into 5 power m. So the given fraction is non-terminating recurring decimal. And 10th bit. 77 by 210. You can write 210 as 2 into 105. This 105 as 3 into 35. This 35 as 5 into 7. Now if you look at the factors of the denominator 210, you can write 210 as 2 into 3 into 5 into 7. Besides 2 and 5, 3 and 7 are also factors. Therefore, the given denominator is not in the form of 2 power n into 5 power m, then the given fraction is non-terminating recurring decimal. Now look at question number 3. Write the following rational numbers in decimal form without performing division. I shall repeat. Write the following rationals in decimal form without performing division. First bit 13 by 25, second bit 15 by 16, third bit 23 by 2 cube into 5 square, fourth bit 7218 by 3 square into 5 square, and fifth bit 143 by 110. Here is the solution. In all above fractions, first of all let us convert the given denominator to the form of 2 power n into 5 power m. Look at the first bit, 13 by 25. You can write the denominator 25 as 5 square. Therefore, this is 13 by 25 is 13 by 5 square. But the denominator should be in the form of 2 power n into 5 power m. Since 5 square is the denominator, you should have 2 square also in the denominator. To get 2 square also at denominator, let us multiply both numerator and denominator with 2 square. Then numerator is 13 into 2 square, that is 13 into 4, by 25 into 2 square is 4. 13 4s 52, by 25 4s 100. 52 by 100, you have to divide 52 with 100. Since 100 means there are 2 zeros, after decimal there should be 2 places, therefore this is 0.52. And the second bit, 15 by 16. Now 16 can be written as 2 power 4. Since 16 is 2 power 4, let us multiply both numerator and denominator with 5 power 4, so that you will get 2 power 4 and 5 power 4 at denominator. Okay, 15 into 5 power 4 is 625. By denominator is 2 power 4 into 5 power 4 is 2 into 5 whole power 4. 50 into 60 into 5, if you multiply, you will get the product as 9375. By 2 5's 10 power 4 is 1 after 4 zeros, that is 10,000. Now, since there are 4 zeros at denominator, there should be 4 places after decimal. Therefore, the value is 0.9375. Third bit, 23 by 2 cube into 5 square. 2 cube into 5 square. You look at this. Here, the denominator is 2 cube into 5 square. If you multiply this with another 5, then it will be 2 cube into 5 cube. To make the exponents of both 2 and 5 equal, let us multiply numerator and denominator with 5. Then the numerator is 23 into 5 is 115. By denominator is 2 cube into 5 cube, that is 2 into 5 whole cube. That is 115 by 2 into 5 means 10 whole cube is 1000. Since there are 3 zeros, there should be 3 places after decimal. Therefore, this is 0.115. Fourth bit, 7218 by 3 square into 5 square. 7218 divided by 3 square into 5 square. 3 square means 9 into 5 square. You write 5 square as it is. Now you can divide 7218 with 9. 9 in 72 8 times, and in 1 0 times, and in 18 2 times. Therefore, if you divide 7218 with 9, you will get 802 divided by 5 square. Since 5 square is there, let us multiply both numerator and denominator with 2 square, so that this 802 into 2 square is 4, by 5 square into 2 square is 5 into 2 whole square. 802 into 4 is 3208, by 2 5's 10 square is 100. Since there are 2 zeros, there should be 2 places after decimal. Therefore, keep the point here, 32.08. Now, fifth bit, 145 by 110. Now, you can divide both numerator and denominator with 11. 143. 11 and 143 13 times. By 11 and 1 time 10 times. 13 by 10. Only 1 0 is there. Therefore, keep the point after one decimal. That is 1.3. Now, question number 4. Find whether the following decimals are rational numbers and expressed in P by Q form. And what can you say about the prime factors of these denominators? I shall repeat. Find whether the following decimal numbers are rational numbers and expressed in P by Q form. And what can you say about the prime factors of the denominator? The first bit is 43.123456789 and it is terminating. Whereas if you look at the second bit, 0.1201200120000120000 and so on. And the third bit 43.123456789 recurring. Now look at the solution. First bit is 43.123456789 and it is stopped there. Therefore, it is a terminating decimal. Since it is a terminating decimal, it is a rational number. Since it is a rational number, you can write it in the form of P by Q. Therefore, 43.123456789 is equal to, you remove the point, you write the total number 43.123456789 by, as there are 9 places after decimal, you divide the given number with 10 power 9 or 1 after 9 zeros. Therefore, the denominator is in the form of 2 power n into 5 power m. Therefore, it is a terminating decimal, you can observe. Now look at the second bit. 0.120, 1200, 12000 and 1240 and so on. It is non-terminating decimal. The decimal place is not ending with the last digit 0. Still it is going on with 3 digits. Therefore, it is a non-terminating. And is it recurring? If you verify, nothing is recurring. It is not in the same part is not recurring. 120 is not recurring. If you get 120, again you are getting another 0. Therefore, no part is recurring. It is non-terminating decimal. It is a non-terminating decimal and non-recurring decimal. So, it is not a rational number. Since it is not a rational number, you cannot write it in the form of P by Q. And whereas if you observe the third bit, it is a recurring decimal. Non-terminating recurring decimal. Third bit is non-terminating recurring decimal. Since here you can observe recurring. This is the symbol for recurring. Since it is non-terminating and recurring, it is also a rational number. You can write it in the form of P by Q.